Uh, so hi, I mean hi all. So in the previous part, I already explained about the level of abstraction. Okay, and I took one example, the half header. Okay, and half header, and I explained how to write the Verilog code of half header in the different modeling. Okay, so this is the half header. Okay, and this is the two input A and B, and for sum I am writing for sum S and for carry C. Okay, so in the previous part I explained already the data flow modeling, behavioral modeling, and gate level modeling. How can you write the Verilog code? Okay, and I explained, so these all are the level of abstraction. We have a four level of abstraction: the I mean data flow modeling, gate level modeling, and the behavioral modeling, and switch level modeling. So I told most of time we don't use the switch level modeling. Okay, so this is the half header. So and in this video I will demonstrate how to write, how to demonstrate the half header. Actually, you know already the functionality of the half header. I mean A and B, that is the 00, 01, 10, and 11. So this thing you already know. Okay, and I will give the proof. I mean, how can you identify this half header? Actually, in the previous part, yeah, I already wrote the Verilog code of half header, like module and half header. Okay, so in the different the level of abstraction. Okay, but in the but you know already the functionality and behavior of the half header. If a and b is 00, sum will be 0 and the carry will be 0. Okay, 01, if you add them, sum is 1, carry is 0. 10, sum will be 1, carry will be 0, and 1 plus 1, sum is 0, carry will be carry will be 1. So actually the importance of the Verilog, yeah, you can say the importance of test bench. How you will identify this half header is working correctly or not? Correctly or not? Actually, you already wrote the Verilog code of half header. So now, how can you identify your half header is working correctly or not? So for this purpose, you need to write the test bench. You need to give the test bench. So there is some syntax how to write the test bench. Actually, so there is a after 10 year after 10 video, I will explain how to write the test bench in very details. For combinational circuit and sequential circuit, there is a different. Little bit is different, but I will explain. Okay, but right now the our target is to understand writing Verilog code, writing test bench, and do this program in the EDA playground, yeah, any software. We have a different software, Synopsys, VCS, Xcelium. But if you are a college going student, you don't have a license of that. Okay, that's a free license. Sorry, free simulator I explained on the EDA playground. Okay, so how can you identify this the half header is working correctly or not? So for this purpose, you need to write the test bench. So some brief idea I am giving here, not too much, but try to understand something. If you understand something here, sorry, then in the upcoming video, I will explain how to write the test bench. One day you will, you will face. One day this thing will be easy for you, and you can write easily test bench of any circuit. Actually, if you go in the industry now, so this is the work of the design verification. If you allotted the DB role, then in this role you need to write the test bench. You need to write the test bench in the you have a very big design, and you need to write the test bench using system verilog, and the UVM also use. Okay, but the verilog is used for the the designing. For DB role, system verilog and UVM. Okay, sorry. So just I am giving the idea of the test bench. So test bench is, it is also a module. Just I am giving the idea, then I will test bench. So it is also a module. Okay, it is also a module. So I am giving here idea, and in the next step I am writing the code. Okay, see. So test bench is the I mean test bench. It is one kind of the module. So here this is the module. So here you can give the any name, TB, yeah, half header TB, yeah, like that. So just I am giving the name test bench. Okay. So here you have option. Just you can give the semicolon. Yeah, after this bracket you need to give the semicolon. No need to write here the port inside the small parenthesis. Okay. Okay. And how many number of input you have already, you need to define the range tab. Okay. So range a comma b, you have a two input, and the output you need to define the y tab. This is the necessary sum and carry. Okay. After that, the module name should be same. Actually, in the two part, in the first part, in the previous lecture, I explained how to write the Verilog code of half header using the behavioral level modeling, and in that I explained module. The name of the module is half header. A half header. Okay. So the same name you have to use. Don't make any difference between them. So name should be same. So name is half underscore header. Okay. And we have a two thing how to link the our module, yeah, design module with the test bench. So we have a two thing, DUT and UUT. DUT and UUT. That is the design under test, unit under test. So here I will use UUT. Okay. And inside the small parenthesis, we have a two option. One is the position association, one is the position or an explicit association. I think some name maybe have a confusion right now. Okay, so one thing is the positional association. TR, positional. Just I am giving the idea right now. Not I am writing the blindly test bench. Okay, the positional association, and one is I think explicit association. Explicit explicit association. I, I mean, what are the difference between them? The difference is in the positional association, you need to follow the ordering. Suppose you define the module and half adder in the previous part, a comma b comma s comma c. So inside this parenthesis, you need to write this order, a comma b comma c. If you write this, if you write like a s comma c comma b, then it will be give error. So in the positional association, this is so this is the drawback. You can't write this way. Okay. So that's why to avoid this issue, yeah, yeah, this mistake, always we will use the explicit association. Okay. So here, okay. So here I will write how I mean what are the syntax. So syntax is dot symbol, then a, in the small parenthesis you need to write the a. So this is the UUT. I hope you understand. Okay. So this thing is there, and here you can change the order. In the explicit association you can change order. No need to follow the order a b c s c. You can write anything, like if you want to write like dot sum. Okay. Dot carry c comma dot b insert parenthesis b. Okay. Just try to understand something. If you understand something, then then it is I mean the better. Okay. So every time the input you should define the res tab, and the output you should define the y tab. Okay. After that, this four line is important. This two, only this line is important. Half header, UVT, and this is a symbol. Okay. After that, you need to give the input. How can you give the input? Like initial, and here if you want to write the more than one initial beginning. So in the first um, so in the first case you have an input 00011011. So I am giving the value of a, that is the one stick of b0. So this is the format to write the number in the Verilog code. I will explain, don't worry. Okay, in the upcoming video. A1 and B I am giving also one stick of B0 and one stick of B. So A का value 0, B is 1. Okay, then A is 0, one stick of B 1. Okay, then actually this is the 0, this is the 1. If you convert in the decimal, then A one stick, sorry, one tick symbol, that is tick symbol, one tick B, and uh, okay, and B is tick symbol. B is also 1. Okay, so I mean one thing is also there. So in the Verilog, actually I explained already what are the difference between C and Verilog. Actually in the C language, this is the different programming, and you cannot contain, you cannot include the delay control. I mean delay means timing information you can't give. But in this Verilog section, you can give this. So for execution, then I will explain. Actually here just I am giving the idea of the compiler directive every time so this symbol is the reverse code. So this is the reverse code, just the so this symbol is on the keyboard, is above the tab button. Okay, so this is the reverse key to time scale 1 nanosecond per 1 picosecond. So how many number of statement is there? That statement will be multiplied with this one. This is the 1 nanosecond is the time unit. This is the time precision. Okay. So here actually this information A is 0 and B is 0. I am giving at at the 0 nanosecond. After that I am introducing the 10 nanosecond delay. This is the 10 nanosecond. This is the 10 nanosecond. And why I'm writing the hash symbol? So because of that, so this is the technique, yeah, this is the way to introduce the delay. So this is the hash symbol. Okay, sorry. So this is the 10, so 10 nanosecond 10. So why I am telling this is the 10 nanosecond? Because of that, this is the time unit, 1 nanosecond per 1 picosecond. So this 1 nanosecond will be multiplied with 10, 10 nanosecond, this 10, 10 nanosecond, 10 nanosecond. So this delay I am including every 10 nanosecond. Okay, and how can you stop this simulation? Yeah, finish with this the simulation using here with the help of the dollar finish. That is the system task is there. Initial, just if you have I mean from this lecture, if you understand something about the test bench, then I will feel like that. Yeah, okay, I'm able to I'm able to what I'm trying to what I'm trying to say here. Okay, initial, beginning, and just I'm betting. Actually, so this is the some difficulty. I mean, so right now I can understand you can you are having feeling and you are facing like that some difficulty to writing the test bench. No issue. One day you will write. Believe me. So after 6 nanosecond, I'm finishing this code. Dollar finish. Okay, this is the system task. Initial, beginning. Okay. So right now, if you are using any simulator like the Synopsys, VCS, and Xilium, Xilium, anything, then no need to write any statement, just put here the end module. But right now I am using the free simulator that on the EDA Playground. So this simulator have I mean don't have the capability. So that's where you need to I mean don't have the capability to show the web form in the window. Okay, so I explained this thing already in the part 1, sorry, in the first lecture. If you want to see the web form in the free simulator on the EDA Playground, so you need to include these two statements, $dump file and $dump var. Okay, $dump file and dump var. So this is the complete code in module. So now I am going to mm, the demonstrate this code on the EDA Playground. Okay, just give me. Actually, I already wrote the Verilog code. The same thing I wrote. No issue. The see here. See, just I wrote here the module half header A and B are the input and sum is the carry. For some actually for better understanding, I wrote sum and carry. Okay, so input A and B, output sum and carry, range sum and carry. Why I am writing here range? Because of that I already explained. If you write the code inside the procedure block like always block, so you need to define the left hand side variable must be a range type. So sum and carry as the range, and this is the XOR symbol and end symbol, begin end. We have more than one statement and in module. And here I wrote the test bench. I mean, test bench means I already explained the test bench is also a module. Okay. Then the input you need to define the range type and output you need to define as word type. This is a common thing, and this is so this should be must. I mean, this will happen always. Okay. Input you need to define range and output you need to define carry. Sorry, where data type. Okay. Then so this is the module name half header. I already explained this module name will be same. This module name will be same. Okay, so this is the half header, and here I am introducing UAT. Yeah, DUT you can also write. And so this is the explicit association. Initial beginning I am giving the value of A is 0, and also if you want to see like that 0 0, then I am using 0. Okay, A value is 0, B value is 0. After 10 nanosecond, I am giving A value is 0 and B value is 1. Okay. Then A is 1, B is 0 means that is the 2, and A is 1, B is 1 in the lastly. After that, the 60 nanosecond, I will finish this code. Why I am telling? Because of that in this compiler, in this Verilog simulator, by default it is taking 1 nanosecond per 1 picosecond. Okay, so see here the time scale 1 nanosecond per 1 picosecond, but here he wrote the nano we can change also, no problem. This is the picosecond, no issue, you can change. Oh, sorry, actually this would be in a small letter, sorry, picosecond. Okay, so this is the thing, and after 60 nanosecond I am finishing this code. Okay, and initial beginning $dump file. So here in the first lecture I explained, if you want to see the waveform in this Verilog compiler, you need to include these two files, $dump file and $dump file. How we can write this thing, I already explained. Okay, see, just I am saving this code, and I'm running this code. Okay, it is telling like that you need to reload. Okay, no issue. I'm using the another EDA playground. This EDA playground, that should be a login. I'm doing the login with the help of the Google. Okay, just I will copy this code. Okay, here I will put Control V, and I will copy the complete test bench. Control C, here the control. This is the simple funda of any engineer. Control C and Control V. Okay, na? Uh, okay. You need to set the language also. This is system Verilog. Okay. I explained na in the part one. We need to set firstly language system Verilog, and then you need to identify the simulator. Which simulator you are using? So I am using. Okay, no issue. This is the pre simulator you can use, and for the waveform, we need to select this one. Okay. Just I am saving this code firstly. So at the top, why I am not writing 1 nanosecond per 1 pico? So you can write here also if you want. Otherwise, here is the common syntax. Is also the, if you want to write, then you can write also. No problem. Sorry, time scale 1 nanosecond, 1 picosecond. You can write also. No issue. Okay. Yeah. Save, and I am doing run. Yeah, simulation has finished. So see here you can understand actually at the 0 nanosecond. So this complete simulation finished after the 60 nanosecond. Here is the 60 I mean 60,000 picosecond means the 60 nanosecond. If you want to change the nano to pico. Okay, okay. So here you can observe at the 0 nanosecond, 0 to 10 nanosecond, I am giving input a is 0 and b is 0. So then carry and sum will be 0. So this is working exactly. Then a is 0 and b is 1. If a is 0 and b 1, carry should be 0 and sum will be 1. Okay, it is working correctly. Then see here a is 1, b is 0. So then carry should be 0 and sum will be 1. It is working as expected. Then a is 1, b is 1, carry should be 1 and sum is 0. Sum is 0 and carry is 1. So after that you can understand. So actually right now I am giving the brief idea actually about the modeling, get level modeling, behavior modeling, data flow modeling, and how to write the test bench. Just try to understand here what are the meaning of the test bench. Okay. If you don't understand completely, no issue. Don't worry. I will explain line by line also in the upcoming video. So just here I explain test bench. It is one kind of module, and by the help of them, you can identify how your code is working as expected or not. Okay, that is the importance of the test bench. Okay, so someone, if anyone want to ask from me, sir, why we need to include the test bench? So this is the importance. If you don't include the test bench, how can you identify the functionality and behavior of the half header is working as expected or not? How can you identify? Okay, so this is the thing. I hope you understand, and in the next video we will meet. Okay, thank you.